One thing is essential. To accelerate decisions, you need innovation that fits the mission. We innovate from AI to zero trust. We integrate using open APIs that you control. We automate with smart solutions so warfighters know and act faster. Your mission, accelerated. Tomorrow's challenges, anticipated. Win faster with Booz Allen.
Hello and welcome to the Emerging Tech Horizons podcast. I'm Arun Serafin, Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. Today we're coming to you from the 2024 NDIA Future Forces Capabilities Conference and Exhibition being held down at Virginia Beach, Virginia. And I'm joined today by Jeff Janey, the Division Chair of the NDIA Munitions Division, who's the Executive Vice President of Munitions Programs at the Czechoslovak Group.
That's correct. Hi, Arun.
Thanks for joining us.
Yeah, it's an honor to be here with you. Thank you.
So FFC, Future Forces Conference, has a wide variety of focuses, but it all sort of circles around armaments, munitions, integrated precision warfare, even robotics.
Yep.
And so tell us, here down in Virginia Beach, what kind of people are we going to run into? What kind of events would people get to participate in?
Yeah, so the customer, it's a joint conference. So there's customers here from the Navy, the Air Force, the Marine Corps, and the Army, plus industry from the U.S. and international allies and partners. So they're all here, and the conference has a number of different briefings and technical tracks, and then we finish it off with a live fire on Friday at Bear Swamp.
Which the conference attendees get to participate in.
Yep.
Right.
Yep.
So your role in all this is both as division chair and then your work at the Czechoslovak Group, right? So
Yes.
Tell us a little about your career progression, how you got to those two positions.
Oh, sure. I'm prior military, but when I left active duty, I started 25 years ago with ATK. Worked up through the ranks with ATK and Orbital ATK, and then Northrop Grumman. And just recently joined the Czechoslovak Group, or CSG USA.
Mm-hmm.
And CSG is a company that's pursuing an acquisition or a couple of acquisitions here in the U.S. That we're currently pursuing. But we also partner with U.S. prime contractors and are looking to be part of the industrial base solutions that are needed now by expanding into the U.S.
And so what's the product line? What kind of technology areas are you working on?
Everything from small cal ammunition to 155 artillery. Those are pretty much my focus areas. But across the CSG portfolios, we also do trucks, medium tactical trucks with Tatra and radars and stuff. So we're also looking for U.S. partners that want better access to the European market. So we're looking at win-win partnerships, and for the U.S. industrial base and for Europe.
So tell us a little bit more about your role in the Munitions Division. What does the chair do? What kind of people in NDIA do you get to work with? What kinds of companies or universities?
Yeah. It's across it's across the scope of primarily industry, but also academia and government customers. So within the Munitions Division, there's two committees. So all the fusing falls under the Munitions Division, and the ICAP, the Industrial Committee of Ammunition Producers. So on the ICAP, that's where we do a lot of close interface with the government on policy and address, together supply chain issues, import issues, export issues. So we're looking for heavy industrial participation in the division to support the ICAP initiatives, and then on the fuse side, it's pretty much all the fuse manufacturers in the U.S. We also have international participation there, and fuse safety, fuse design. There's a lot of really fun technology and innovation in the fuse space that is really exciting here at the show.
Yeah, the fuse part of the show strikes me as a science and technology event.
Oh yeah.
So what are the science and technology, emerging technology innovations that are finding their way into the fuse world?
Well, I think industry has been, sometimes the legacy defense contractors will take umbrage to, that only Silicon Valley guys can do defense innovation. Um, what industry can do with fusing, gun hardening electronics, and what they're able to do with breakthroughs in material science by applying that into the fuse space is really exciting. We're now using fuses as guidance mechanisms. We're guiding bullets. So the ability to get more processing power out of a package that needs to survive 100,000 Gs, set back, set forward, balloting force is just an incredibly rough environment, is really amazing.
So some of the electronics that are going to go into a package like that, fired at 100,000 Gs, is doing what? It's processing what? How much power are we talking about processing?
Well, there's a number of different ways to utilize some of the gun launch forces with setback generators, batteries that need to survive, and also alternator based things by using spin to help power, in which case you can generate a lot more power than you need. Um, if you think about a system like PGK or the Precision Guidance Kit, what that does for artillery, that same type of approach can be applied to smaller calibers.
And so you're actually using some of the energy of the launch to power the smarts of the kit.
Yeah.
And if I think about the processing power
Yeah.
that sits on these kits,
Yeah.
Is it computing really complex things, or is it?
It can. It's available for products that are in development or that can be fielded in the near future.
So it could potentially take in sensor information.
Yes.
About targets.
Yeah.
It could potentially act as a control system for the munition.
Yes.
So you're blurring the distinction between what's a munition and what's an unmanned air system at that point, right? Or is there already no difference?
No, I haven't thought about it that way, but yeah, that's true.
Yeah. So I know, in my past, we used to think about fusing technology, and we were very excited about MEMS, microelectromechanical systems. So what's happening in fusing technology? That's particularly interesting.
Yeah, there's a lot of MEMS technology that's getting incorporated into modern fuse design. Oftentimes when you come to a show like this, you'll see things on display that are fielded. It's a little, you don't always get to see what's in development
in the
labs, or unless you come to a show like this and you go to the fuse track.
What up, man?
There's constant briefings right now as we're talking that are up in 3 different rooms just talking about fuse technology from industry, academia, and the government labs.
Right. So there's even basic research going on.
Oh yeah.
As well.
Yeah.
As you know,
breakthroughs breakthroughs in material science are often the key to innovation.
Right. Key to everything.
Yeah.
And that's one of the powers of an event like this, right? So you
Mhm.
can put together an event that has that university community, but needs to get a better understanding from industry what the real challenges are, particularly manufacturing challenges. And then needs to talk to the operational community to say, okay, that's a clever thing for you to do, but we really don't need it, right?
That's true.
And
Yes.
so you can put together rooms like that where you can have that kind of discussion.
Yes. And there's a lot of examples of those types of things where even something as simple as the primer in a small cal, munition, the primer, what initiates the propulsion train, you know, using nanoparticles for that is an improvement. But if you need
because of the efficiency of combustion.
right,
Okay.
but if you can't work with it because you need plasma to generate the nanoparticle, but if it oxidizes inside of 15 seconds when it's exposed to air, then it's you can't transfer that out of the lab very easily to a Lake City where you're making 1.5 billion rounds a year.
So that brings in another set of emerging technologies from manufacturing technologies.
Oh yeah.
Right. So how are you working with the manufacturing technology community in this space?
So you'll see some of them here on display in the booths here. You'll also see some papers again in the tracks upstairs for the presentations, and then that's where we're doing. They have the ability to have government people see the presentations and interact during all the sessions here. So it's a great way for people to get a broad audience, because the Army isn't the only one that buys the equipment.
Right.
Northrop Grumman's buying equipment. General Dynamics is buying equipment. Everybody here is buying stuff for their manufacturing capacity expansion, for surge, everything that we need. There's a lot of buying of equipment and capital expenditures right now.
As I think about the space you're in, and I think about DoD's acquisition system, which is perfect in every way, one of your advantages is these systems are very disposable. They're intended to be disposable. And when we talk about other systems, platforms, there's always this desire that, gee, why couldn't we just use disposable systems? It'll make our life and acquisition so much easier. You guys are in disposable systems, basically.
Yes.
So what are your acquisition challenges?
The acquisition challenges are, for the most part, we have one customer. We have the DoD, the government customer. We want to, companies are always wanting to expand that through international sales to partners and allies. But again, there's a constraint on exportability. But really, one of the key things, and it's one of the topics we're touching on here in the conference, is stockage levels. Current events are highlighting the need and some of the problems that we're having with surging capacity to meet current needs. So the stockage level of munitions is a really important point, not only for the U.S., but for partners and allies.
Right. And so in that case, it's sort of a little less the department doesn't know how to buy these things at the rate you can produce them. It doesn't have a buying strategy that makes sense to industry.
In some cases,
okay.
Yeah. I mean, there are cases like the Army, the single manager for conventional ammo, the SMICA approach, where For conventional ammo, you have Picatinny Arsenal and the Joint Munitions Command working together and purchasing ammunition for the other services. So the Army buys for the Marine Corps, the Navy, the Air Force. They generate some buying power there by doing that.
Right.
But that's unique. That doesn't happen as much on the missile side or the bomb side, or I mean, it does to some extent, but we're at Picatinny, the Army uses multi-year contracting or family buys. So there's a little bit more predictability than perhaps on the missile side. You hear a lot of issues in the missile space about no minimum sustaining rates, no multi-year contracts, and those are things that industry and the government are trying to work out and to get the budgets aligned to support that.
Right, and that's been a big focus of Mr. Norquist, who's the CEO of NDIA, and he's pushing on some of these policy financial management issues.
Yeah.
Mm-hmm. When I think about emerging technologies in this space, I'm curious about these are smart systems now, require power, can do some clever processing. What's the impact of something like AI, you think, now and maybe into the future on these systems?
Oh, it's exciting how many presentations we have going on at the show here that are based on AI. It holds tremendous potential. Not only on manufacturing or munitions technology, but also in areas that are outside my division, like guidance and control. You know, AI applied to guidance and control and sensors has huge potential.
For example,
the take for example a small UAV that could use its camera alone to do guidance and navigation with a camera alone. So no GNSS,
right?
No need for GPS,
Right.
No need for Galileo or anything like that. Just camera.
Just because there's going to be enough video and data
Yep.
for the system to be smart enough to do the navigation without those extra.
To go where it wants to go and do what it decides to do.
Right. Is there any kind of, because of the smarts in these systems, is there a cyber threat that you worry about at all? Or is there something about launching at 100,000 Gs and the speed that things go that cyber's not an issue for us?
Well, cyber's always an issue for us at the foundational level,
the manufacturing level.
Yeah,
sure.
Yeah. So everything that goes into running the GoCo plants, the government-owned, commercially operated, and the GoGo plants, what are the organic industrial base and the inorganic base. Everything surrounding there has a cyber focus, and it just moves up from there. But critical infrastructure, cyber concerns, it really starts there and then works on operational security and all those things. But yes, big concern for our partners and allies as well.
And we've talked about this with other people here at the show. Another emerging technology that some are claiming is going to obviate the need for more traditional munitions and armaments is directed energy systems. So what are your thoughts on, where do you think they're going to have an impact or not?
There's a place for it, for directed energy. Certainly, whether it be EMP, RF defeat of, there's certainly applications for it in in the counter UAS space. One of the biggest force protection issues that our forces face is the threat of these small UAVs. So directed energy has application there. I think getting the swap right,
Size, weight, power.
size, weight, and power, still has a lot of work to do. We're spending, the government's spending a lot of money in that space, and so it'll get there. There's some use and application of it right now around the world.
But when I say things like, "Wow, it's got an infinite clip,"
Yeah.
do you
No.
believe that?
No. No.
because of the power required, and because
Yeah, there's a space for it, but I'm a munitions guy. I'm a bullet guy. It's hard to find a target that isn't best addressed with a bullet.
one of the classic things about being very clever with your technology, emerging technologies, putting them into these systems, which have traditionally been one disposable, second lower cost, is that I start to build exquisite systems and I use them in situations where my targets are not exquisite at all. Very low tech, very cheap. And classically, shoot a $10 million missile to destroy a $1,000 hut or something. So how do you balance that? I want to use the best technology, but these are supposed to be lower cost, high inventory systems.
Yeah, and for the user, at the user level, they should be telling themselves, at the user level, they should never worry about something that they have issued to them, what it costs, because you don't want to get killed for lack of shooting back. But is that sustainable? Is that, and it's not. If you look at how a country, I'll just use a general example. So if a country is getting, these onesie, twosie drone attacks, and they're using an F-15 with AMRAAM missiles or AIM-9Xs, that's okay if it works, but eventually
it's not scalable.
It's not scalable, right? You're going to lose that eventually. But what that drone can do to critical infrastructure, you almost can't put a price on it if it takes out a refinery, for example. Huge implications. Or, so it's okay to do that, but it's not sustainable. You need to find more systems that are capable of defeating those systems and sensing them. Sensing them is a big part of, detect, ID, track, and defeat. It takes a whole system to really get them. But yeah, there are plenty of technologies here at Future Forces that are cheaper than what these small drones are.
So another area ETI has done some work in is energetic materials. And I think you talk about that at this event as well.
Yep.
There's great growing concern that the U.S. will lose its lead in advanced energetic materials. Can you talk about the state of play and how the U.S. is doing in developing advanced materials? And do you have concerns about future of electronic energetic materials?
Yeah. So I feel comfortable with where we're at from a, advancements in energetic material and the output, highly charged grains, the application of insensitive munition technology for what we use in our systems. What I think we're all more concerned about is the supply chain issues. The fact that the U.S. currently doesn't have a TNT plant, so we're relying on international sources. One of
when was the last U.S. TNT plant in operation?
I believe it was in the early 90s
Hmm.
and was bracked.
Hmm.
It was bracked in the 90s. And we lost our TNT plant. We lost our ability to do nitroguanidine, so which is key for triple base propellants. So we've been sourcing that through, allies and partners since, and a lot of precursor material and chemicals are, come from China, and so supply chain concerns and constraints.
Down at the strategic material level,
Yeah,
even, right?
yeah, and you'll see it as well on the metal side. So it's more about precursor ingredients than and the total availability, and the rapid availability to surge production and stuff. That's the bigger concern, not only within the U.S. but really worldwide.
So we're gonna have to wrap up, but
Yeah.
I'm gonna with one final question. So you said there's universities that participate at this event, and with the division, what do you think you need for the workforce for the future in the broader munitions area? What kinds of disciplines do people work in? Why is it an exciting field for them to get into? How would you get a younger generation excited about this?
Um, I think it's well, there's any discipline you're working if you're coming out of school. I was just came out of a briefing where a professor from KU was briefing a hypersonic projectile thing. I was amazed, and he was recruiting students up there to go to KU and work on it. But really, any mechanical field, um, electrical engineers were always, for as they apply to the fuse space. But if you have a sense of, if you have a love of country, if you have a love of freedom, and you're in the engineering space, working in defense is so fun. You get to do so much fun stuff, and it's technically very challenging. You know, I'll go back to the 100,000 G's.
Right, right. And then on Fridays you get to shoot stuff.
Yeah, well, you do.
So with that, I want to thank Jeff for joining us here on the podcast.
Thank you.
Um, thanks you all for joining us as well. I want to tell you about a couple of upcoming ETI events. On October 18th, with our partner, the MITRE Corporation, we're running a workshop on the use of AI to support the acquisition workforce. It's going to be held in Northern Virginia at MITRE's Tyson's Corner facility. Registration's open now. Please visit the NDIA or ETI website to get more information on that. Go visit the NDIA and ETI websites to hear about all of our upcoming events, webinars, our conference that'll be next summer, as well as our educational offerings, including our monthly Tech 101 series. If you enjoyed this podcast, please like and subscribe. We always want that. And give us an email if you've got ideas for future podcast episodes or guests. Special thank you to Melanie Yu and Daniel Park for producing this podcast. Thanks again, Jeff, for joining us today.
Thank you. It was an honor.
And thanks to everyone for tuning into Emerging Tech Horizons.